Hey everybody, welcome to this topic's video that takes this NAEP item that compares the graphs of two runners in a race and has you interpret parts of the equations, the slope, points of intersection, and the intercepts, and see what they mean in terms of this problem, which just says that there's a race that's been going on, but at 11 o'clock they realized that runner A was 10 miles from the finish line, runner B was 7. And we can see that runner A crossed, even though it was further away, crossed the finish line before runner B did, right? So I thought it'd be kind of neat to make a simulation of our two runners as they're going based off of our graph and how we can look at the parts to help us with that. So I'm going to open up GeoGebra, and what I'm going to do is create this real quick. I'm going to make a finish line. Since runner A was 10 miles from the finish line, I'm going to make the x-axis in terms of miles. And B is 7 miles from the finish line, so I'm going to put its coordinate here at 3, right? Which is just actually using your point tool, making your points and making them a little bigger and change their color. The finish line is just the x equals 10 line, which maybe even I can make stand out even further if we wanted to. Okay, so now we have to figure that at 0 time, runner A is 10 miles from the finish line, runner B is 7. So now what we need to do is create a slider, and the slider is going to control time for us. So I'm going to call this T for time, starting 0 seconds and going to, we don't really know exactly what we want time to be, but if we look at the graph, which is this, time right now is in terms of hours, which I'm going to make my time in terms of minutes to make the animation look better. Okay, so we go up to 2 hours or 120 minutes. So in our slider here, I'm just going to go from 0 time up to 120 minutes. Oops. Jumping up by a minute, we'll say. So click apply. Now this creates a slider that just goes from 0 to 120. So this is going to keep track of our time in minutes. Okay. I can right click the slider and go to animation on, and it'll just animate the slider, just making it jump by seconds. Sorry, I'm making this video during a class right now, so you can hear some of my students. So now that we have this time here, what we want to do is move the points in their speed relative to every minute, right? So as time increases per minute, our distance to the finish line should decrease, right? We're getting closer to the finish line. So to figure out that, runner A, we got to figure out its speed. Well, it was 10 miles away at 0 time. And if each tick, there's 1, 2, 3, 4 ticks for every hour, so each tick must be 15 minutes. Therefore, it looks like in 75 minutes, an hour and 15 minutes, runner A crossed. So he went 10 miles in 75 minutes. So that is our speed for runner A, 10 miles for every 75 minutes. So that's going to be the speed for A. Runner B looks like it went 7, started 7 miles away, and in 120 minutes, or in 2 hours, went those 7 miles. So we know that it went 7 miles in 120 minutes. So that's the speed of runner B. So then all we have to do is figure out, okay, how do we make this point move across this horizontal line? I'm going to double click the point A so I can redefine this. And I'm just going to put the coordinates in here that it's going to be the 10 miles for every 75 minutes, that's its pace, times t, because t, as it moves, will tell us how far horizontally the point moved, and that'll be the x-coordinate of our point. So I'm going to say comma, and we're just going to leave it on this horizontal path. So because I place A up here at 6 on the y-axis, its y-coordinate's always going to stay 6. So I'm going to click OK. So we have a variable in our x-coordinate, which is going to make this point move horizontally. And so now as I move t, notice A is going to move. Okay, let's do the same thing for B. B, I'm going to double click. the x-coordinate is going to be its speed times time. So this is for runner B that went 7 miles in 120 minutes. Okay, times t, that's our time variable, comma, and the y-coordinate is 2 because it's on this y equals 2 line. So when I click OK, oops, I need to add to this, it's starting 7 miles away, so it's actually starting at this x-coordinate of 3. So I need to have 3 plus this, which is going to change the value from 3. So now when t is 0, we get 3, but now both our points or our runners are moving at different speeds, and we can see when they're about the same, and it looks like they're going to be 5 miles away, somewhere around 5 miles away from the finish line when they meet, and then runner A just takes over, which is what that intersection question is really implying here. So now if I want to run my slider, we can just see the runners finishing the race here. A overtakes B and crosses in no time, and in our 2 hours, B finally gets across. So there's my simulation of this comparing graph question that takes all the parts here that it was asking in the NAEP item and puts them in some kind of context here. Okay, so I hope that made sense, guys. Good luck.